In our next unit of physics, we're learning about momentum and how momentum is transferred. In order to learn about momentum, we first need to define momentum. Now, momentum is a term that you've likely used in your everyday life. And a quote that we've heard in the past in this course is that physics is a foreign language that sounds just like English. I don't know exactly who to attribute that quote to, but this is a great example of that. Think about all the times you've used the term momentum before. If you had to write out a definition of momentum, what might you write? Typically, the answers I receive have something to do with how big an object is, or perhaps how fast it's moving, or maybe a combination of the two. In physics, the definition of momentum is actually in terms of an equation. The equation is that the momentum, or a lowercase letter p, is equal to an object's mass times its velocity. You'll notice that momentum is a vector, thus it has that vector symbol on top of it, and it has the same direction as the velocity of our object. Thinking about the units of momentum, we're multiplying mass times velocity, and we know mass, the standard units are kilograms, and velocity is meters per second. Therefore, momentum is measured in kilograms meters per second. Another term that we'll see in this unit is something called impulse. Impulse is a measure of both the magnitude and the duration of a force that's exerted on an object. We've used the term impulse or maybe the term impulsive before in our everyday lives, but impulse in physics has a very unique meaning. To be able to determine the impulse on an object, the first thing we need to do is draw a force versus time graph, such as the one you see on the screen here. In this case, we have a force that starts out at a constant 2 newtons for 3 seconds, and then the force decreases to 0 over the next 2 seconds. To be able to find the impulse exerted on our object, we would need to find the area of this force versus time graph. To do so, when I'm saying the area, really I mean the area from the graph to the horizontal axis. So to find that area, we would be finding this distance in here. It's a square, and then the distance of this triangle, or sorry, the area of this triangle right here. If I found that area, I'd be multiplying a force in newtons times the time in seconds. Therefore, the units of impulse are newtons times seconds, or newton seconds. We'll put these two concepts to use in class and see how they relate to each other more clearly as we do an investigation.